Hello everyone, welcome to G-Centric. So in this lecture we will continue with the graph theory. Okay, so we will see what do we mean by incidence matrix. Okay, I'll write over here incidence matrix. Okay, so let us take this previous example itself. Okay, where we have got 4 nodes and 6 branches. Okay, so I have made the directions for this one. So it is the oriented graph. Okay, so now to make the incidence matrix, keep it in mind that it is dependent on nodes, number of nodes. So while writing the column, we will consider nodes for the incidence matrix. So what are the nodes? 1, 2, 3 and 4. So there are 4 nodes. Okay, so if I take over here 1, 2, 3 and 4 nodes. Okay, so let us draw the lines for this one. Okay, then here in this way, this is there and 4 node. Okay, now what we have to fill over here in this horizontal line, it is the branches. So keep in mind incidence is nodes versus branches. Okay, because in further when we do the Cutset or Tieset matrix, so this is important, which versus which we are going to draw the matrix for. Okay, so this will be over here horizontal, it will be the branches, number of branches. Okay, so how many branches are there? 6 branches are there. So 1, okay, 2, okay, let me draw this first one with the black pen, 2, then this is 3, 4, 5 and 6. Okay, so there are 6 branches, 5 and 6. Now see over here, first we will consider node 1. Okay, stand over here, this is node 1. Okay, see how many branches are going away from this one? 1, 2, 3. So there are 3 branches for this node 1. Now see the direction. Okay, if it is outgoing, okay, if the arrow is outgoing, okay, this is first condition, and if it is incoming, okay, there are 2 conditions. When it is outgoing, you can take either positive or negative. So whichever you take, the incoming should be opposite of that one. So if I take outgoing as positive, then incoming will be negative. Okay, so now this branch 1 and branch 2 are outgoing. So I will write it as positive 1. Okay, plus 1 and here also plus 1. And 6 is incoming. So I will write this as minus 1. So rest of the branches will be 0. Okay, similarly for coming at node 2. Over node 2 also 2 is incoming, 3 is incoming, 4 is incoming. Okay, 3 branches all are incoming at the node 2. So I will write minus 1 and minus 1. So rest will be 0. Okay, coming to node 3 over here. So there are again 3 branches, 4, 5 and 6. All are outgoing. Okay, 4, 5 and 6. So rest will be 0. And node 4, okay, here is node 4. 1 and 5 are incoming. Okay, 1 and 5 are incoming. 3 is outgoing. Okay, so write this as 1. This will be 0. Okay, so this is how you can calculate for the incidence matrix. Now we have to draw the matrix. Okay, so this is just the table that we have drawn. Now if you observe the table, see here for this branch, okay, and this node, this column, plus 1 minus 1 equal to 0, plus 1 minus 1 0, minus 1 plus 1 0. Okay, so the sum total for this matrix will be, or the table is 0. Okay, so this is for the incidence matrix. Given any number of branches or any number of nodes, this will hold true for both the any type of incidence matrix that you draw. Okay, the column value will be 0. Now this is the incidence matrix. We will draw the matrix now. So this is incidence table and we will draw the incidence matrix. Okay, how do we write this one? This is the nodes, these are the branches. Okay, so this branches represents the voltage. Okay, it represents the voltage. So I will take it over here. I will write V1, V2, V3, V4, V5 and V 6. This is equal to, I'll just write here, okay, over here, okay, this we have to fill, and this is node voltage V1, okay, you can take Vn1, Vn2, Vn3 and Vn4, okay, for the node voltages. Now, okay, and you can also write this as in the form of E1, E2 or E3, E4. Okay, let us take E1, E2, E3, E4. Okay, so both means it is the node voltages and these are the branch voltages. Okay, so now I will put this one. This was in horizontal. We have taken it as vertical. So this will be like a transpose. So 1, 1, 0, 0, minus 1. So this is 0, minus 1, minus 1, 0, 0. So here also we have 1, 2, 3, 3 zeros, positive ones, okay, minus 1, 0, 1, 0, minus 1 and 0, okay. So this is the matrix for this one. Now you can write the equations. This is of no use now. How do you write the equations? You can get the branch voltages through the matrix. Okay, so first is V1. V1 equal to, okay, see here, E1 minus E4. This is the multiplication, right? E1 minus E4. Okay, so E1 is over here. Okay, this is E1. This is the node voltage E1 minus E4. Okay, so see here the direction of the arrow, it is from higher potential to lower potential. Similarly, here also it is indicating higher potential to the lower potential. It will be same for all the voltages. So V2 when you write, it will be E1 minus E2. Okay, see here E1 to E2. So it is flowing from higher to lower potential. Similarly, V3 is equal to minus E2 plus E4. 4 to 2, right? It is flowing from 4 to 2. That's why it is minus E2 and plus E4. Higher potential to lower potential. Similarly, with V4 you can write minus E2 plus E3. V5 is E3 minus E4. V6 is minus E1 plus E3. Okay. So here, these are the branch voltages with respect to the node voltages. So this is about the incidence matrix. Next we will see about the Tieset matrix. Okay. So in this video only I will, in this graph itself I will take the Tieset matrix. Now incidence matrix was related to voltage and nodes. Okay. So here it is related to links. Okay. So the Tieset matrix is related to links. Okay, what do we mean by links? We have already seen in the previous lecture that to complete the graph, whatever it is required with the twigs, we will add the links that will give our complete matrix, complete graph with the oriented graph. Okay, so now I will take out the Tieset matrix. Tieset matrix. What it is related with? It is related with the links. Okay. So here number of links will be equal to number of fundamental loop. Okay. We will come to what do we mean by fundamental loop. Okay. Before that, if I have, okay, so this is the tree. Okay. And these are individual are the twigs. So this is 2, this is 4. And this is 3. Okay. How do I form the link now? By completing the graph with dotted line. Okay. So this is the links. Okay. And this graph is 5. Here is the 1. And this is 6. Now, what do we mean by fundamental loop? So that fundamental loop should consist only one link in it. Okay. See now, if you consider this loop. Okay, in this loop, these both are twig. This is only one link. So this is fundamental loop. Similarly, in this also, if you take like this, in this loop, these 2 and 3 are twigs, 1 is link. Okay, here also 5 is link, 4 and 3 are twigs. So in each of the loops, there is only one link. So that is called as fundamental. If there are more than 2 links, then we will call it then it is not a fundamental loop. It's just a loop. Okay, so this Tieset matrix is nothing but what versus what? Links versus loops. Okay, so now to draw the table, okay, let us draw the table over here. Here similarly again it is branches, here it will be links. Okay, so what are the links we have here? 1, 5 and 6. Right here 1, 5 and 6. Okay, draw this one. 1, 5 and 6. And what are the branches we have again? 1, 2, 3, 4, 5 and 6. Okay. So now 1, okay, this is link 1. So we have link 1. Okay, keep it in mind, the arrow mark will syncing with the link will go with the positive one, whereas over here it is opposite or same. Okay, the twig has same direction, so again it is positive. If you come over 2 here for the twig, it is opposite direction, so it will be in negative sign. Okay, so there is one more topic that has left out in the previous for the incidence matrix. Its rank will be, okay, rank of incidence matrix will be n minus 1, okay, and its determinant will be equal to 0. So this is the 2 points, please keep it in mind. Okay, just write it in your notes for the incidence matrix. Okay, so coming over here, 1 and 3 we have positive direction. Okay, 1 and 3 positive direction, 2 is minus 1, the rest will be 0. So fifth one, okay, here it is 5 is plus 1, again 3 is plus 1, 4 is minus 1. So this is plus 1. Okay, 0, 0, 0. Sixth one, so 6 is plus 1, 2 is plus 1, okay, and 4 is minus 1. Okay, so when you add here you won't get 0. Okay, that is only for the incidence matrix. Okay, so this is the branches versus links. Now here these branches indicate the currents. Okay, so this indicates the currents. And now what does this links indicate? Those also indicates the current, but the loop currents. Okay, so you can take this as I1, I5 and I6. Okay, and for this one you can take I1, I2, I3, I4, I5, I6 as branch currents. Okay, you can give it as the different terminologies as well, so that's not a issue. Okay, you can take this as IL1, IL5 and IL6. Okay, let me write here. So here we have I1, I2, I3, I4 and I6. So this is where we have got the links, these values. Okay, and here it is IL1, IL5, IL6. Okay, so plus 1, minus 1, plus 1, 0, 0, 0, 0, 0, 1, minus 1, 1, 0. Then we have got 0, 1, 0, minus 1, 0, plus 1. Okay, so you can write this IL1 equal to I1. Okay, plus everything is 0. Next IL2 is this is IL1. Okay, then we have I2 equal to minus IL1 plus IL6. So you can complete this I6. So here the rank will be B minus N plus 1. Okay, so that is the rank of this Tieset matrix. Now coming to the Cutset matrix. Okay, that is the last topic in this one. Then we will solve some 2 questions based on this chapter. Okay, so now Cutset matrix, it is based on the twigs. This was based on the links, and Cutset matrix is based on the twigs. Okay, so we will take the Cutset matrix now. Okay, so Cutset matrix is based on the twigs. So number of twigs will be equal to number of fundamental cuts. Okay, so now what do we mean by fundamental cuts? We will see. First we will draw the twigs over here. So I am just doing it this way. Okay, solid lines basically they are twigs itself. Okay, so let me draw it with this one itself. Okay, so this is twig with the solid line. Okay, don't get confused. or I'll draw it over here itself. Okay, so this is solid lines are twigs. Okay, we have to put a cut. We have to put cut such that only one twig is present. Okay, so if I do here, okay, this is cut 1. Okay, so this cut is in this direction. Okay, this is for the cut 1. Okay, next see here, only one twig is present and 2 links are there. So that is what we will call it as fundamental cut. Only one twig should be present. Similarly here also I can do here. Okay, this is one more cut. There is only one twig and the third cut is over here. Okay, this is cut 2. So this we will take in this direction. Okay, so now we will draw the matrix diagram for this one. Here we have got how many cuts? So we will take it as number of twigs, and here we will take branches. Branches we know 1, 2, 3, 4, 5 and 6 branches are there. Count the twigs 2, 3 and 4. Okay, 2, 3 and 4. These are the twigs. Okay, so now come here. Stand over here in front of the cut. See, we have cut in this direction, which is indicating the direction of 2 itself. Okay, so 2 will be plus 1, 6 and 1. Okay, see here, 1 is also in this direction, but 6 is opposite to the cut. So this is 0, this is 1, 0, 0. Okay, cut 3. Okay, no, sorry, the twig 3 is over here. See here, 3 is in this direction, so it will be positive 1. Okay, 5 and 1 are opposite to the cut. So this is minus 1. Similarly over here, it is in the direction of 4. Okay, and 6 and 5 as well. 4, 5 and 6. So the rest will be 0. Okay, so it is these branches again indicate the voltages. Okay, branch voltages, and this is the node voltages. Okay, so if I write here V1, V2, V3, V4, V5 and V6, this will be equal to, okay, this is Vn2, Vn3, Vn4 node voltages. Okay, so 1, 1, 0, 0, minus 1, 1, 0, 1, 0, minus 1, 0. So 0, 0, 0, 1, 1 and 1. Okay, and the rank will be equal to n minus 1. Fine, this is about the Cutset matrix. Now we will see some of the 2 questions. Okay, then we will end this chapter and move on to the locus diagram. Okay. Okay, so coming to question number 256. In a completed graph, there are 66 branches. So what they have given? They have given the number of branches is equal to 66. We have to find the fundamental loop and fundamental cut set. Okay, basically number of fundamental cut set and loops. Okay, so for that, to find the fundamental loop, okay, we have formula number of fundamental loop is equal to b minus n plus 1. Okay, so but we do not know what is n. For that we have to first find out using the formula nc2. Okay, so this is n of n minus 1 divided by 2, right? This is nothing but number of branches. Okay, so we have got number of branches as 66. Okay, so when we solve this one, what we will get? N is equal to 12. Okay, n is equal to 12. Now put it over here. We have 66 minus 12 plus 1. Okay, so basically this is equal to 11. 66 minus 11 is 55. So number of cuts is 55 and number of fundamental loops is 55 and number of fundamental cut will be n minus 1. So 12 minus 1 which is equal to 11. Okay. So next coming to this question, identify which of the following is not a tree. Okay, so tree it's like we should not form any type of loop. B, E, G, H. Okay, so B, E, then we have here H and G. Okay, so basically this is not a loop. So it's a tree part. Okay, so option 1 is not correct. Coming to option number 2. D, E, F, G. Okay. So we have D, E, F and G. Again it's not a loop, okay, forming, so it's a tree. Okay. So next coming to option number C. A, E, G, H. Okay. We have here A, E, then we have got G and then we have got H. Okay. Right. So A, E, G, H. Is it forming a loop? We have A, then E, then G and H. No. So this is not in this way. So it is first we have to go here, then G, then E, E. Okay. So it is not a tree. Sorry, it's a tree. A, D, G, H. Okay. We have here A, then we have here D, H and G. So now it is forming a loop. So this option is not tree. Okay. So this is about the graph theory. So we will end the graph theory over here and shift to the locus diagram, which is the last part of this network theory. Okay. So after this, this is just the basic questions that has been asked in CS or in electronics part. Okay. For electrical, it's not so important, but if you know, it's a advantage for you. Okay. Thank you.